Hello, everybody. Welcome to our free lesson on Introduction to Functions. This is Pre-Algebra. I also do cover this topic in Algebra 1, but today is going to be catered to all our Pre-Algebra students in the chat here today. Put a W in the chat if you're already familiar with functions, and a plus in the chat if, you might be familiar with it, but you're not too sure about everything that has to do with functions. Let me just make sure my stream is working indeed on my phone. Here we go. All right, looks like we are live. I see RN Jewel W in the chat. Thank you for that. That's a great start already. I'm Eddie. Let me introduce myself really quick and we can get started with today's lesson. So I'm the lead math teacher here at my EdSpace. I've been teaching for over 9 years now in high school classrooms and college lecture halls. I've private tutored every grade level from 6th grade math all the way to students in college preparing for graduate school. So I guess you can say I bring a very wide breadth of knowledge in mathematics teaching to you here at my EdSpace. 3 things that you can do for me today to make the most of your time here with me is 1, have fun and stay locked in. Number 2, do not be afraid to participate in today's chat. Mistakes are so good and important for a part, essential, not just important, but essential for a part of your learning experience. Whenever you make a mistake and you fix that mistake, you retain that information 10 times longer, and that's research-based. And number 3, ask questions whenever you have any at all related to the lesson. There's no such thing as raising your hand or waiting to be called on in this online platform, online lesson. I'll be checking the chat every 5 to 10 seconds here, and I'll be able to answer any question that you have. And with that, let's get started. Here we go. So, a function is a rule that maps one number x to another number y. An example of a function machine can be found here. So x will be what we call our input, times the 2, then plus the 3 gives us our y, which we will consider our output. And later on, I'll show you how many things in mathematics will be alphabetical. In this case, x comes before y in the alphabet, and so does I in comparison, in relative to O. So now a function machine above will multiply our number by 2 and then add 3. Now, this type of thing will come up again, and we should already know our order of operations. Many of us know it as PEMDAS. But for those of you that don't know order of operations yet, function, notation, and functions really help us to reinforce that skill as well. So, given this, let's find the output given the following inputs. So here we're inputting a 3, and we're adding 1 to it. In the chat, let me know what you get for this. Very simple, straightforward example to start. This is how all my lessons start. I always start with something that I believe all students should be able to access and enter the lesson with. So if you're here with me today, we got 3. We plug it into this function machine where we add 1 to it, and we get 3 plus 1, which is 4. We're going to get more complex than this eventually, and don't be afraid to participate in the chat here. Let's try out the second one. We have 5 as our input, and we'll be multiplying it by a negative 5. So essentially what we have down here, we plug in a 5, multiply it by negative 5. We know 5 times 5 is 25. Don't forget that negative, and we'll have negative 25. Next, we have a negative 9 divided by a negative 3. What would we get here? Really curious as to what you all think in the chat here. This is very essential to know operating with negative numbers. Really important. I'll give you an opportunity here in the chat. I'll give us some wait time here. Negative 9 divided by negative 3. So what's happening here is we're inputting this negative 9 into this function. That's what this arrow means. And it goes through the function. This negative 9 gets divided by a negative 3, and we get some answer as a result. And that answer would be, well, a negative divided by a negative is a positive, and we've learned this in a previous lesson in our pre-algebra course already. And we know 9 divided by 3 is a 3. So we have positive 3 as our final answer here. All right. This helps us to really get to what a function is, even if we replace these numbers with letters. And oftentimes, Algebra just becomes a whole bunch of letters and rules if we don't understand what we're truly doing here. So if we have this x as our input and we're adding 2 to it, then just like we've been doing, we can rewrite this as x plus that 2, just like that, and we're done, right? We don't know what x is. Eventually we will, but right now we do not know what that x is, other than that it is the input and we'll be adding 2 to it. Likewise, when we have y divided by 5, we'll get y just divided by 5 like this. All right. There is a slight lag. I believe there's about a 10 to 15 second lag between the stream and when you see it on your screen. So if you're at a W, if you feel like you're good so far, give me a W in the chat. If you feel like, you're still kind of getting the hang of it, but you'll get there eventually, growth mindset, give me a plus in the chat. And some of my students, whenever I do this W versus plus, some of my students will put a W plus together to let me know that, like it's making sense for sure, but I would like to see a bit more examples. So they put a W plus in the chat. They get very creative like that. We built a very engaging and supportive community on our platform. So nice, Kanav, W in the chat. I love it. I love it. I love it. Welcome, welcome. All right, so let's take a look at some more practice problems. Find the output given the following inputs. Let's take this step by step. If we have this 4 as our input, the very first thing we'll be doing to this is multiplying by a 2. 4 times 2 gives us an 8. And after that, we'll be subtracting the 5. So 8 minus 5 gives us a 3. Still very, very straightforward. We're taking it step by step. Now, next, we have a -1, subtract a 7. And so many students might say -6 here because they think, oh, a -1 and a 7, you think 6. But reminder, if we're subtracting from a negative number, we're going further in the negative direction. So -1 minus 7 is -8. And by the way, in the chat, don't be afraid to participate. You can just blurt out answers in the chat whenever you feel. That's the beauty of being online. You'll never be interrupting me in any way, and I'll constantly be paying attention to the chat. And then after we get this -8, I can multiply by a -2. Negative times a negative is a positive. 8 times 2 gives us that 16. My Moon, welcome. I don't know if I'm pronouncing your name correctly, but thank you for the W. Looks like Maimuna Sissoko. Great name. Love it. All right. This next one, we have an input of 15. Subtract a 1 first. I get a 14. Then I divide by 7. 14 divided by 7 would give us a 2. For those of you that are also new to YouTube, reminder that there is a live button, like an icon that says live right next to the volume bar. So if you take a look at that, you can click on the live and make sure you're right there with me in the lesson so that you're not behind and chatting behind maybe. All right, this next one. Now, again, we'll take it step by step. The first thing we do to this x here is multiply by a 2. So I get 2x. We don't know what x is, so this is how we write it. We get 2x, and then we tack on a 1, a plus 1. So we get 2x plus 1, just like this. Thank you, Maimuna. Next, this very next one, x minus 5 gives us an x minus 5, and then we divide by 2. It is very important here that we put the entire expression x minus 5 divided by that 2. We cannot just put the x over 2 or just the -5 over 2, but we need the entire x minus 5 divided by the 2. Awesome work so far. Awesome, awesome work. Let's keep this ball rolling. Here we go. So I want you to try some of these. I'll give you a little bit of time to try each one of these and put your answer in the chat whenever you have an answer. I'll slowly start explaining them step by step for those of you that are still maybe a little shaky on this. I'll still continue to model with this, but this is my time to let you go a little bit and try it out on your own as well. This first step in this first problem is pretty simple. 5, and then we got that minus 1. 5 minus 1 gives us a 4. And before I forget, you can access all the problems that I'm solving today within the lesson via the workbook, which is linked in the description below. So if you click on that workbook link in the description, you'll see all the problems that I'm solving. And this is one of the first 2 steps of our 4-step method here at My Headspace. We have the lesson live, and you have a workbook to follow, so you don't have to copy down anything and focus on the learning, right? You can focus on the learning and pay attention to the explanations instead of frantically trying to, copy down what's on the board or on the screen in this case. So this 4, where does this 4 go? It goes within this little box. So now we have the square root of 4, which is equivalent to 2. So for those of you that have never seen a square root before, basically what a square root means is what number times itself gives us the number within the square root. So what number times itself gives us a 4? Well, that number is 2. And that's how we got this 2 here. Let's try this next one out. We have 1 minus a 5. 1 minus a 5 gives us a negative 4. We have a positive 1, and we go 5 to the left from 1, and we'll land at 4 left of 0. Now we're going to plug this into this box, and a lot of my students will make a very common mistake and say this is negative 16. But reminder, whenever we plug in a number and it's squared, the entire thing will be squared unless otherwise stated. Negative 4 squared means negative 4 times another negative 4, and that gives me positive 16. So again, you have all the questions on your screen. Feel free to answer whichever one in the chat whenever you feel whenever you feel literally, and I'll be happy to engage with you in the chat. This next one, we have 4 times 2. 4 times 2 is 8, and I'll be plugging this into this box. And this is really getting us ready for function notation, which is actually just substituting, right? Functions are all about substituting some input that gives us a unique output, and more on that in a little bit. Cube root of 8 is asking us what number times itself 3 times gives us that 8, right? Before with the square root, we said what number times itself gives us a 4. Nice, Kanav. And for this one, we're asking ourselves what number times itself 3 times gives us an 8, and that number indeed is 2. W Kanav in the chat. Awesome stuff. Awesome work. All right, let's keep this running. So next lesson, we will start looking at function machines in reverse. We're going to be talking about inverse functions in the next lesson. But today, we're going to identify some unknown inputs given the outputs. So it's important to know inverse operations, and this is kind of planting the seed of inverse functions later for the next lesson. So if we have something times 2, then subtract 5 from it to get 9, in reverse, what would I have to do? What would I have to do? Do I divide by 2 first? Do I add 5 first? Do I subtract a 5? Do I multiply by a 2? Well, we'll be using inverse operations here, which means moving in reverse. What's the very last step we did before we got to the 9? We subtracted a 5. So if we want to undo subtract 5, we want to add 5. Similarly, the very previous step was to multiply by 2. So our very last step will be to divide by 2. So let's take that step by step. Follow the arrows. 9 plus 5 gives us a 14. And then 14 divided by the 2 gives us a 7. Now you can always check your answers with inverse operations or just the operations that we got to get to 9. So in this case, 7 times 2 is 14, and 14 minus 5 is in fact 9, and that's how we know we did this correctly. You can try either of these next 2 problems on your own as well. Whenever you get it, plug it into the chat and we'll get right on with it. This one, we start with a number, we add 1 to it, then divide by 2 to get to a negative 5. So now we're going in reverse, so we'll be using our inverse operations of whatever's written here. The inverse operation of dividing by 2 is multiplying by a 2. And the inverse of adding 1, or in other words, undoing addition of 1, will be subtracting 1. And now follow the arrows. -5 times 2 is -10. And subtract the 1 from -10, and it's not -9, it'll be -11 because we're moving further 1 in the negative direction. Some of your teachers at school might have called this a flow chart, and in a previous lesson, we have covered flow charts already, so I would say, this is the same thing as a flow chart here as well. But for those of you that may have not seen this type of flow chart before, this is often called a flow chart. All right, last one here before we head into our definition of functions. This number that we don't know yet is divided by 5. Then we take the square root of it to get to 2. What's the inverse operation to square rooting something? In the chat, let me know. What's the inverse operation to square rooting something? And as you type that out in the chat, let me ask you, for those of you that don't know, oh, Kanav, that was super quick. Squaring, right? We can square it just like this. Beautiful. Wow, already there. So for those of you that might not be aware, think about it this way. Earlier, we said the square root of 4 is equal to 2. If we squared both sides, does it remain true? The square root of 4 squared is 4, and 2 squared is 4. It does remain true, and that's why squaring a square root undo one another, right? They are inverse operations. Nice stuff, Kanav. Now, dividing by 5, the inverse of that would be to multiply by 5. So let's take it step by step. Follow the arrows. 2 squared is 4, and then 4 times 5 gives us 20. We can go back in this original order, original flow, to get back to 2 as well. So it looks like little circuits. If you've ever done any physical science or like physics, you may have seen circuits before. These flowcharts do kind of look like circuits. It's very good preparation for that as well. All right. Let's keep it moving. So I think of a number, multiply it by 3, then add 8. The answer is 35. What was that original number? Now, this is creating equations here, right? Creating equations, writing equations. We've done stuff like this. This is, in this case, it's a 2-step equation. Once you have an answer, let me know what you got in the chat. I know Kanav's been really great today. Same with Maimuna. Let's check this out. Oh, okay. Kanav already has an answer. Awesome. We think of a number. We're going to multiply it by 3, then add 8 to get to 35. So inverse operations, we subtract 8 to undo this plus 8. So we get 27, 3 times this box. And now to undo the multiplication, we will divide. And 27 divided by 3 is 9. Nice stuff, Kanav. A+ to you. Now let's try out this one. Let me know what you get in the chat. I think of a number, take the square root, multiply the result by 6, then add 11. Let's do this step by step. I think of a number, I take the square root of it, I multiply the result by 6. I multiply the result by 6, then I add 11. Afterward, I subtract 3, and the final answer is 20. Let's combine like terms where we can. I know 11 minus 3, I said the answer, is plus 8 equals 20. Now I'm going to subtract 8 on both sides because that is the very previous thing that we did. And I get 12 on the right, I get 6 radical box. Divide both sides by 6, or in other words, 6 times what number gives us 12? That number is going to be 2. And Kanav told us earlier we can undo a square root by squaring it. And if we square both sides here, box will give us 2 squared, which is equal to 4. Give me a W in the chat if you're good so far. We're about to ramp up the challenge level a little bit here, finally getting into functions, function notation, and all that in a little bit. But before I move on, I want to get a quick gauge, a temperature check of where you all are at. Give me a W if you're good to move on. Give me a plus if you have some questions. And reminder, if you have any questions at all throughout the lesson, just type it right on it into the chat. I'll see it and respond as soon as I see it. Let me know how y'all are doing. W's in the chat if you're good to go, you're ready. pluses, if you're just in that growth mindset mode, I don't understand it quite well yet, but I know I will by the end of today's lesson. W's and pluses in the chat. Awesome, Kanav. Thank you for the big W. Love it. Love your energy today. If anybody else wants to chime on in as well, feel free to do so. Here we go. So, function notation. In elementary or middle school, you'll have seen function machines that look kind of like this. We have some input and we have an output, and we have some rule that assigns each input to its unique output, right? You can think about a function as a rule that assigns whatever is inputted into it to a specific output, right? It's basically a rule. A function is a rule. If you put one number into this machine, it will give you one out. So input and output. Definitions. What you put into a function is called the input. What comes out is known as the output. The set of possible numbers that you can input into our function is called the domain. The set of possible outputs that you obtain as a result of our domain is called the range. So let's paint a little picture here. We have x comma y. That's in alphabetical order. X comes before y. We also know input and output. I comes before O. We now also have domain and range. D comes before R in the alphabet, right? All of these are in alphabetical order, which is coincidence? I think not. We also have horizontal and vertical. So whenever you think about, I know a lot of students, even when I was teaching AP calculus, some students would oftentimes make the mistake of calling the y-axis the x-axis. I know, kind of embarrassing, but you know, everyone makes mistakes, and maybe they just had a bad day that day. But we can memorize it or remember it. Sorry, not memorize, but understand it as in alphabetical order. X comma y, H comma V in alphabetical order once again. And later on in trigonometry, later on in your mathematical career, you'll also see cosine of theta times sine of theta. And if you just look at the beginning letters, C comes before S. So there's so many things that are in alphabetical order here in mathematics, and that's the beauty of it. You need to remember for a function today that every input has one unique output. If an input has multiple outputs, then it is not a function, right? It is not a function. One number in, one number out. That's a function. 1 to 1. So let's check this out. We input an x into this function, and we get 2x plus 3 out. What does that mean? If I have some function, f, right, f, and I plug in an x, I get 2x plus 3. That's what this means. But when I first teach functions here, like I am right now, I use boxes to help you all not get confused with what an x is. Because oftentimes when you see that x, it's one of the first places, kind of instances where I see students start to hesitate, start to get a little intimidated because we're not used to seeing letters, right? We already have 2 letters in this equation. We're not used to seeing letters in mathematics. We're used to seeing symbols, but not English, right? So think about the x as a box. A box also stands for an unknown. So if we want to find f of 2, and 2 is a part of this box, let's color code this 2 and these boxes as well. We know that once we plug in, once we substitute this 2 into the box, it will be cubed and then plus a 1. So keep in mind here, the green boxes, all we did was we substituted whatever we wanted to plug in 2 into that box. So now 2 cubed means 2 times 2 times 2. Cubed means multiply whatever's in that box times itself 3 times. So it's not 2 times 3. It's 2 times itself 3 times. That gives us an 8 plus 1 is equal to 9. Try out letter B. Let me know what you get in the chat. Letter B, we have f of negative 2. And so we have that green box. All of negative 2 is going to go in that green box. I'm going to cube it, like it says here, and then add a 1 after I cube whatever is in the box. So in this box, we have a -2. Let's plug that in. Treat the box with parentheses. That's a very good habit to build that solid foundation here in pre-algebra. I just also want to note, we don't take shortcuts, right? No shortcuts here in pre-algebra, no shortcuts in algebra 1. We can only afford to start to learn these cool shortcuts that we learn later on, like patterns. Maybe in geometry, maybe in algebra 2, definitely in pre-calc because we want to work a little bit quicker. But in pre-algebra and algebra 1, we do not take shortcuts. We need to build a solid foundation where we are able to stack knowledge on top of that foundation. If we're taking shortcuts while building the foundation, then the foundation, we're going to crumble later when we start to try to build on top of what we have already learned. So pre-algebra is all about building that solid foundation that we can build upon in future courses as well. So I'm really happy you're here with me to do that. So -2 cubed will be -2 times itself 3 times. So -2 times -2 is a +4, times another -2 is -8. For those of you that are more visual learners, this is what we are doing. And -2 times -2 gives us a 4, and times that -2 gives us a -8. So if -8, don't forget that +1, and we get -7 as our answer here. We're going to be going into some practice problems. So if you're good to go, you're feeling confident about these practice problems that are about to come up, give me a W in the chat. If you have some questions, you're a little bit shaky here, give me a plus in the chat so that I know where you are at. Feel free to ask any questions at any time. In my lessons right now in pre-algebra, we have about 70 to 80 students in the chat at once, and many students are asking the same question. Or if a student asks a question, 4 or 5 other students will go like, oh my goodness, so-and-so, I had the same question. Thank you for asking. And then once I answer the question, everyone goes like, oh, in the chat, feel like, oh, it makes sense. Rithul, W, thank you for that W. Wow, that yellow profile circle is really bright. I love it. Very noticeable, unique. Love that. All right, however everyone else is feeling, feel free to participate. And let's get on with some of our practice problems. Here we go. So changing the input. These questions might be slightly different from what you see in the workbook. Again, you can access the workbook by clicking on the link in the description below. You'll have the entire lesson there. Nice Kanav, W, big W's from Kanav and Ruthul. So now given f of x is equal to x squared plus 5, write down expressions for f of 2. Letter A says, Suranya, welcome. Big W from you as well. Beautiful. So we have f of 2. And keep in mind, whenever we have something within the parentheses of our function, we substitute all of it into every x that we see. So something I like to do, again, is to put an x, right? Put a box around it. Put a box around it. So what we get here is 2 squared plus 5, and we can box these 2's to make sure that we have plugged in 2 into all the x's that we see in our original function. So we have 2 squared, that's equal to 4, plus the 5. That gives us a 9, just like this. All right, I want you to try out this next one in letter B, f of -5. I want you to try it out. I'll give you about 15 to 30 seconds here. Try this out and let me know what you get in the chat. See, Suranya Basu, nice. Thank you for that W again. Awesome. Rithul, Kanav, Maimuna, I know y'all are here. Orange Jewel is here as well. Beautiful. Love it, love it. F of -5. What would that give us? I can help you all out here by putting a box around this -5. I know we'll have some box here. It will be squared, and we will be adding a 5 to it, just like we have in our function here. So once we plug in that -5, some common answers here, I would guess, would be maybe a -20, because you might have forgotten that whenever we plug in a -5 or any negative number within this box, we must square the entire thing, right? We must square the entire -5, not just the 5. So if I were to rewrite this, I can rewrite it like this. And -5 squared is the same thing as a -5 times another -5. That gives me 25, because a negative times a negative is a positive. Plus a 5, that's equal to 30, just like that. Okay. Try out letter C. Let me know if you get an answer for letter C in the chat. We have f of b this time, f of b. Really quick, if you are struggling with negatives or operating with negative numbers, here's a little trick that I've noticed that students have really enjoyed in the past. We know that if something good happens to a good person, that's good. And by the way, this dot is for multiplication. If something bad happens to a good person, that's bad, right? Nice, Kanav. B squared plus 5 is absolutely correct. If something good happens to a bad person, that's not so good, right? So we'll consider that bad. But if something bad happens to a bad person, that's not so bad, right? So we consider it good. Now, obviously not the most socially accurate or moral thing to say, right? But I've noticed that students really, really like, or it really sticks in their minds when, I give this little cute example. So hopefully that helps you remember it as well. So something good happens to a good person, that's good. And then you go down the line like that. So f of b, great, Kanaf. We have b squared and then plus a 5. There's nothing else we can do here because we do not know what this b is, right? We do not know what this b is. B is unknown, so we keep it as is. All right, letter D is somewhat of a challenge problem here. We have f of 2x. Let me know if you have an answer to this one. Don't be afraid to make mistakes because once again, when you make a mistake, you're giving yourself an opportunity to fix that mistake as well. And when you do that, you retain that information 10 times as long, or 10 times as stronger, 10 times as long, kind of different, but the research has spoken. Nice, Kanav. Great answer. So we have 2x squared plus 5, but we have to remember the entire 2x is within the box. So if I were to rewrite this, I can treat the box as parentheses. And whenever I square something, when in doubt, rewrite it, right? Don't think, oh, do I distribute that square to both the 2 and the x, or do I not? Just rewrite it, right? Don't try to do everything in your head. Try rewriting it. If we have something squared, that's that thing times itself, right? So if we have 2x squared, we'll have 2x times 2x. Well, 2 times 2 is 4, and x times x can be rewritten as x squared. So don't try to memorize all those exponential properties when you're working with simple functions like this. Just rewrite it whenever you can. And we get 4x squared plus 5. Again, I'm always trying to focus on true understanding and not just memorizing formulas, because once you get to high school, can you guess how many formulas do you think you have to memorize in high school across all the math classes you take? Let's say from Algebra 1 all the way to AP Calculus AB. How many formulas in total do you think you have to memorize throughout high school, throughout 3 to 4 grade levels of mathematics? And reminder, with these number of formulas, you also have to know how to apply them correctly, right? You can't just memorize them and know what they are. You have to truly know how to implement them into certain situations, know when something is right to use for a certain scenario that you're given and things like this, right? Any guesses in the chat? How many formulas do you think you are expected to memorize by the average teacher in Kanav says, I'm an IM2 and there are a bunch of formulas. Ooh, Kanav, if you're an IM2, you might enjoy my geometry course, or maybe even Algebra 2 next year, because next year you'd be taking IM3, right? And IM3 is, I remember IM2 is mostly, I don't remember, but I know that IM2 is mostly a lot of geometry. Then IM3 is what you take right before pre-calculus / trig. So IM3 is a lot of algebra 2, if we were to correlate the two different types of curriculum. Thank you for sharing that, Kanav. Exciting. No wonder you're such a pro at this today. Thank you for your interaction with me. Thank you for your engagement today. Appreciate it. All right, so we got 4x squared plus 5. Oh, back to the formulas. You have to memorize over 120 formulas throughout your high school career. Now, some of you may think, wow, that's a lot. Some of you might think, oh, that's not as bad as I thought. But remember, again, you have to remember how to correctly apply all of these formulas as well. And what I'm here to do here at my Headspace is I don't need you to memorize 120 formulas. Maybe 50 across your entire high school career, because I focus on the understanding, truly deep understanding of each little formula that you might learn. So, and a lot of them, if you think about it, are connected, right? You can derive certain formulas from others. So that's true understanding. That's true deep understanding. And that's what we focus on here. Let's try another one to really understand function notation here today. Last slide for today here. Given f of x is equal to 3x plus x squared, write down expressions for the following. Kanav, I think you might enjoy some of these here. So let me know what you get, or anyone else in the chat that like to chime in here today. F of hello. A function with an input of hello. We have hello in a box. We recognize this time we don't have just one x within the function equation, but we have two of them. So what that means is when we have hello in a box, we must substitute each green box with a hello. So we'll write this out. We'll have 3 times some box plus box squared. Just like this. Nice, Kanav. I hope you had fun typing that out as well. So hello will go into this x. We're substituting here. We're plugging in, right? Plug in. Hello here and hello there. And boom. That's what we're going to focus on today. We're not going to focus on distributing anything. That doesn't really have much to do with function notation. Let's focus on what a function is. Right? Let's focus on the idea, the concept of a function. The skill of simplifying and distributing we'll work on later. Letter B, we have f of x plus 1. So in this case, we will have x plus 1, all of it in a box. So box, box, and we have equal to 3 times plus this squared. So for this one, we have x plus 1, all of it within each of these green boxes that we had for x up here. I've noticed that students really struggle with plugging in more than one term within the input of x into the function equation. And that's because they start thinking, oh, do we just add 1 to both of these like this? And that's how I know that you did not learn it. You did not obtain true deep understanding of a function, right? When we're plugging in x plus 1 and all of this is within the parentheses, all of x plus 1 will go into our green boxes. And this is the power of using boxes and not an x, right? And trying to do all algebra. Make it fun, right? Draw these boxes. So I have x plus 1 here and x plus 1 here. So what does that mean? That means 3 times all of x plus 1. Remember, you can treat these green boxes as parentheses, and all of x plus 1 squared. And you'd go ahead and distribute combined like terms afterwards. Let's try letter C. Letter C, we have f of 2x. F of 2x then will be, let's slowly start to break away from these green boxes and use parentheses instead. We will have 3 parentheses plus parentheses squared. So keep in mind, we're still doing the same thing, right? The green boxes have just become the red parentheses. So if 2x here and 2x here, we can go ahead and distribute and combine like terms thereafter. Let's check out letter D. F of x cubed. We're plugging in an x cubed into wherever we see parentheses or that green box. This will give us 3 times some parentheses plus some parentheses squared. Beautiful work, Kanav. We're going to plug in x cubed into the parentheses here. So we have x cubed here and x cubed here. Let me know what you get for this one. This will be 6x plus 4x squared when you do simplify. Nice work. And you can go ahead and factor here as well, right? You can factor out a 2x if you would have liked. And that would have gotten you 2x times 3 plus 2x, something like this, just for fun. All right, now for here, we can get 3x cubed plus x to the 6th power, because whenever we have a power to another power, we can multiply those two powers. Or, as I said before, the true understanding here is that if we square something, it's that thing times itself. And then we think about, what does x cubed mean? X cubed means x times x times x. So then times another 3 x's will be times x times x times x. So we have 6 x's in total. Boom. That's where we got that 6 from. And that's where that exponential property, that pattern, comes from as well. Whenever we have a power to another power, we can multiply those two powers. And that's because of this pattern that we observe. Letter E, last one. How do we do letter E? It looks like this cubed is outside of the function. It is not attached to the x, but it is outside of the function. Think about it for a second. What could that possibly mean? That means all of f of x is being cubed. Well, what is all of f of x? All of f of x will be 3x plus that x squared. So what you're telling me is if we have f of x cubed with a blue box around it, then this will equal whatever f of x is equal to within that blue box cubed. That's what an equality means, right? An equality means both sides need to maintain the balance, right? We need to maintain the balance on both sides. Well, f of x is equal to 3x plus x squared. And reminder, any box can be rewritten as parentheses. So we have 3x plus x squared and that cubed. And this is going to be a longer expression here, just because we're going to have 3x plus x squared times 3x plus x squared times 3x plus x squared, and we'll probably end up with 4 separate terms here, and that'll be a lot of algebra to get through. All right, give me a W in the chat if today's class helped in any way. Maybe like for Kanav in IM2 already, pretty good with functions. W if you were able to reinforce some of the learnings that you have had in the past. W's in the chat if you learned at least one new thing today. W in the chat if you may not have understood everything, but you persevered through today's lesson as well. And with that, today was just one piece of all of pre-algebra. We actually covered introduction to functions last week on Wednesday in our February module. January, December, November, October, you can see everything that we've covered already within pre-algebra. And if you join today, you get access to all the recordings of the lessons that we've done in the past as well. Big W from Kanav, beautiful. And you can try out all of this for 7 days for just $7. Full access, you can cancel anytime. And this is what you get from me here at My Ed Space. 2 engaging live lessons per week. So just like what you got today, 2 of these a week, Monday and Wednesday, 5 to 6 p.m. Pacific time. You get video recordings. So every live lesson is recorded, including this one. So you can go back to any part of the lesson that you may have missed, or maybe you discussed this in your school a month later. You can come back to the recording of this and see, oh yeah, I remember when Eddie did it like this. And you get unlimited replays, as many replays as you'd like. Professionally designed lesson materials for structured learning, like the workbook that you can access or that you did access in the description below via the link. So that you can focus on the learning and not frantically copying everything down on the screen. And the video recording also puts you at ease that you don't have to get everything during the lesson, right? You can always go back to it anytime. After every lesson, you get a unique set of practice problems as well that I've created with video solutions after you complete the practice problems. I mean, this 4-step method has helped thousands and thousands of students, over 17,000 students to be exact. And you also get an unlimited guided help from our AI math coach. Hundreds of 5-star reviews. You can read it here. You can pause the video here later. And if you are interested, grab your parents for 60 seconds. Or if they're already next to you, parents, welcome. Your child just finished a free pre-algebra lesson and wants to try a 7-day trial. $7 for 7 days. I mean, $7, that's the cost of a coffee these days, right? And for 1 week, it's less than one meal, right? $7. I think you would find it pretty worthwhile. You get your money back guarantee and you can cancel with one click. And after your $7 7-day trial, it's still only $149 a month after that. I know that might be a high price to pay for some folks, but really, if you think about it, for 8 lessons a month, each lesson comes out to less than, $15 a month, something like that, or $15 a lesson. And you get all these resources, right? You get all these resources, practice problems, step-by-step video solutions, which is another mini lesson, basically. You get engaging lessons twice a week. If you have a tutor, after you leave the tutoring session, all the work, all the learnings are gone. It's not recorded. But all our lessons are not only live, but they're also recorded. And you get unlimited guide help from our AI math coach that I have personally trained to teach like the way that I do in my lessons. And here's the lesson schedule. I'm currently teaching 4 courses. Today was pre-algebra, Mondays and Wednesdays, 5 p.m. Pacific time. Each lesson is 55 minutes just to give me that extra 5-minute break before the next lesson commences. So if pre-algebra, algebra 1, geometry, algebra 2, you can come back to this or take a quick snapshot of this as well. And to protect you from any risk, we provide a full refund guarantee, no risk. You can scan to start. I'll have a quick Q&A here. If you have any questions at all, please feel free to ask in the chat. But you can scan the QR code to start, 7-day pass. You can start today and you'll have until next week to access all the modules, right? It's not just this module in February, but once you join, you get access to all the recordings from previous months. What is that? That has to be at least 28, maybe 30 lessons that we've already covered throughout this school year. Maybe you're going over something right now in school that you might be struggling with. And if you found it on one of the previous modules, you can go back, access the recording. Once you're done with the recording, you get access to practice problems. And once you submit those practice problems, your answers to those practice problems, you get a mini lesson from me again of video solutions, of me solving every practice problem step by step as well. So not only do you get these live lessons, not only are they recorded, not only do you get the workbooks that help you follow along the lesson more smoothly, and not only do you get practice problems after the lessons, but you also get those video solutions as well. And I can't forget the AI math coach that I've trained that doesn't just give you an answer to the problem. Because if you're just asking AI for answers, you're not going to remember them on the tests, right? If your child or you yourself are struggling on tests, that means you're not truly understanding the concepts and skills that were required on that assessment, which means you are maybe looking for quick answers. We're not about that here at MindSpace. We're about true learning, real deep understanding, so that even over the summer and you come back to school, you still have that understanding and you remember it for the following course. Because math is one of those courses, right? Every year it compounds. It compounds. So don't wait till the next academic school year. I will see you soon in my live lessons. myatspace.com/7, $7 7-day math pass. You can scan the QR code or you can go to this site. Let me know in the chat if you've already signed up. I'm looking forward to seeing you there with whichever course you feel that is right for you at this time. This is also an opportunity to get ahead as well. I know we're near the end of, or we're nearing the end of the school year, preparing for next year as well. We will have a much larger course offering next year. We are planning on that. So that's some exciting things in the future. So if you get accustomed to our platform early, next year will be even more fun. All right, everybody. If you have any questions, please feel free to leave them in the chat. I will be here for another minute or so. But otherwise, thank you for joining on in, and I will see you in my live lessons. Thank you, everybody. I'll be here for another minute, though. That was a fun lesson. Shout out to Kanav, Suranya, Rithul, Maimuna Sisoko, and RN Jewel for your participation today. If anyone else would like to ask a question, feel free. Or any of you that were going through this, taking all questions. Be here for another 30 seconds. Water, nature's greatest gift. All right. I will see you in my live lessons, everybody. Scan that QR code. Go to myatspace.com/7. I hope you enjoyed today's lesson on Introduction to Functions. I'll see you soon. Have a great 3-day weekend. Bye-bye.